All right, so we're going to start right here with squares. So these three topics right here, honestly, this is the new stuff, okay? You've probably seen an exponent before. You've probably seen a square root symbol before, which is called a radical. But you have not ever dealt with a cube root before, okay? So before we talk about any of the other stuff, I want to make sure we know these three. So let's talk about this. This is, of course, something that is squared. So this is a square. And what this literally translates to is this is a number times itself. So for example, 4 squared equals 16. And then we would call 16 a perfect square. We'll talk about that in a second. Okay. So 4 squared is 4 times 4, which is 16. Okay. Now, here's the most important question. This is the biggest kicker for me for all of this. What is the opposite of addition? Subtraction. What is the opposite of multiplication? So you need to, now that those are like second nature to you, you need to understand that the opposite of squaring is square root. Next week, when we do Pythagorean theorem, there will be squares in your equations. And to solve those equations, it's not going to be, oh, I got to get rid of this square by dividing. That's not the opposite operation. The opposite operation of squaring is going to be square root. So let's talk about square root. So we're writing this one right here. We're going to write square root. And rather than like that check mark box thing, it's called a radical symbol. But I think of a question when I see square root. Every single time I think of the same question, okay? And you said it earlier, exactly when I see this. When I see this, the question is, what number times itself has that value? What number times itself has that value? That's what square root is. So my example here is the square root of 49. Okay? I'm going to ask myself, what number times itself has the value of 49? And the answer is 7. Not 7 squared. I'm just getting the absolute value of that square root. So to kind of bring it like both ways, I could say 7 squared is 49. Or the square root of 49 is 7. Like I said, next week, that is how you will solve Pythagorean theorem every time. You will have to use these interchangeably. So I think the best note for you to write for both of these is that they are opposites. I think that's an important note to make. Okay? Cube root is kind of just another part of this. It is not an opposite of squaring and square root. Okay? But the best part about this topic, like I said a second ago, is that this can be done in the calculator. So take your calculator right now, on and clear, and let's deal with those 7s again. If I wanted to get 7 squared, I could literally press 7 and squaring. I could press that number without pressing second, and I have 7 squared, 49. Awesome, right? And if I wanted to do square root, always clear, so go press clear. Remember that square root is second and then square button right there. That opens your radical brackets. You could put the square root of 49 and then you're going to get that value of 7, right? I would make a little note here because you don't want to forget how to put that in the calculator. That would be terrible because we don't want to have to solve this. I would make a little note right here in your calculator that the buttons you're pressing the second button, and then you're pressing the x squared button. Okay, so even if you're in the middle of practicing this stuff, you can always refer back to that. Okay. Now, most of what we do the next couple of days and next week with Pythagorean is going to be square and square root. But it is important for you to understand and see what cube roots are. Okay. So this right here is called a cube root. And you should see the 3 exponent in front of the radical symbol. And it also has like a question that goes with it. So when I see a square root, I say, what number times itself is that value? What do you think the question is for a cube root? What question are you going to ask yourself when you see a cube root? Take a guess.
How many squares is this?
We're on the right track. So if this number is 7 times 7 to get the value of 49, this is going to be what number times itself is that value. And I know that sounds like a weird question. You could say times itself 3 times, or you can say times itself times itself, because the little number is 2 for the exponent is 2 here, and the exponent is 3 for cube root. Correct. So we're going to say what number times itself has this value. Okay, that's a question mark. And again, the calculator can do this for us, because you're going to learn in a second, you know a lot of these perfect squares, because you know 3 times 3 is 9. The perfect square of 16 is 4 times 4. The perfect square of 25, 36, 49, 64. You know your math facts. Cube roots, we don't know those. I don't know those by heart, right? Because I don't know what 4 times 4 times 4 is, right? I don't know offhand 14 times 14 times 14. So we're going to let the calculator do these cube roots for us. We just have to enter it in. So again, you're going to write the cube root. So we're going to put a little 3 exponent. Pay attention. Gavin, you're writing. Exponent of 3, radical symbol, and then we're going to find the cube root of 64. Okay. Now, when we enter cube root in the calculator, it's 1 extra step. So please make sure you're watching me right now as I enter this in. Okay. This is 1 extra step. It's a little bit trickier than square root. All right. So everyone, I would watch first, then enter second. So to enter in a cube root, you need to press the number 3. Then you press the second button. Then, don't press it yet. Watch me point. We are not pressing the x squared button. That is just for square roots. If you look right above it at that up arrow button, it is a radical symbol that has an X above it that kind of looks where the 3 would be for cube root. We're going to press that one. And then if you look at your screen, we should get 3 with that little exponent, the square root symbol, and now we can put anything in this value as cube root. Okay? So the cube root of 64 has a value of 4. So what does that mean? That means that 4 times 4 times 4 has a value of 64. Okay? And let's take a quick little calculator note up here. We pressed the number 3. We pressed the second button. And then we pressed the up button. Okay? All right. Last couple things, kind of before we start listing out and practicing these radicals. So we are going to find the values of these square roots of numbers based on where they fall around perfect squares. So you have to know your perfect square. So what is a perfect square? It's a number that has an exact value when times itself. So you're going to list them all at the bottom in a second. We're going to list all of these times itself, times itself, times itself in a second, okay? Because we're going to use them as a guide for the rest of the week. But of course, the ones we know that 1 times 1 is 1, 2 times 2 is, no, 4. 3 times 3 is 9, and then 16, and then 25, and 36, and so on, right? So that's all those perfect squares. Every number in between those. So looking at like 9 and 16, 9 is a perfect square because 3 times 3 is 9. That's a rational number. So that kind of goes right into the next one. A rational number is what? It can be accurately rounded. Okay? It can be accurately rounded. So the square root of 9, exact value of 3. That's a rational number. But all the numbers in between 9 and 16, 10, 11, 12, 13, 14, and 15, they're going to be irrational because their values are going to fall in between those perfect squares. Okay? So that means that irrational numbers cannot be accurately rounded. And I could put the square root of 9 in the calculator. You know that I would get 3. And you should know that if I did the square root of 10, it's going to be irrational, right? The value is actually right after 3 on the number line. So the square root of 10 is about 3.162. I can't accurately round it. It goes on forever. Okay? So in a second, we're going to get all these perfect squares, and we're going to start seeing where they fall on a number.